Alrighty there, statisticians. In this video, we're going to talk about our standardized test statistic, our z-value, and our p-value. So remember, our formula sheet does not give us just here's how to find z. So our standardized test statistic measures how far a sample statistic is from what we would expect if the null hypothesis were true in standard deviations. So our standard test statistic is going to be our z equals our statistic minus our parameter divided by the standard deviation or the error of that statistic. So if we think back to 9.1 and our 80% free throw shooter, to be an 80% shooter, so think back, the shooter claimed to be an 80% shooter, but in one sample made 32 out of 50 shots for a p-hat of 0.64, which is 64%. Does this one sample provide convincing evidence that the player is not an 80% shooter? Well, we said, so let's take a look. Let's calculate how unusual a p-hat of 0.64 is for an 80% shooter by finding a standardized test statistic and the probability that p-hat will occur. So we're going to remember the mean of our p-hat is going to equal p, which in this case is 0.80. So then we find our standard deviation for p-hat, which is p times 1 minus p-hat divided by n, take the square root of all of that. So we're going to get 0.566 for a z-score of negative 2.83. So this means p-hat is 2.83 standard deviations from the null hypothesis of 0.8. And is that unusual? Oh yeah, 2.83 standard deviations away from the null hypothesis, or what I expect, is very unusual. Okay, let's determine the probability of an 80% shooter making 32 of those 50 shots for our p-value. So when I find the probability of what he actually did, that's going to be my p-value. So the probability that z is less than or equal to negative 2.83, we're going to do our normal CDF. Let's go ahead and put in that parentheses, where we have our lower value of negative 1,000, upper value of negative 2.83, standard deviation of 1, and we get 0.0023. This small probability confirms that there is convincing evidence that the player is exaggerating, and we should reject the null hypothesis that he's an 80% shooter. I need to fix that spelling right there. And there we go. Small p-values lead us to reject the null hypothesis. Remember that. There is convincing evidence for the alternative hypothesis, so we reject the null. Let's try another example. So remember that walk into school one that we did earlier? So Deanna would like to carry out a test that had an alpha of 0.05. So that's the number I'm going to check it against, is my significance level. My null hypothesis is 0.3 versus an alternative hypothesis of greater than 0.13. And P is the true proportion of all students at our elementary school who typically walk to school. Check if the conditions performing the significance test are met. Well, we already did that, and the answer was yes, they were met. So explain why the sample results give us some evidence for the alternative hypothesis. There is some evidence supporting the alternative hypothesis that P is greater than 0.13 because p-hat is 0.17, which is greater than 0.13. The results of this one sample is greater than what I was looking for the null hypothesis. So there's some evidence. Is it convincing? That's the question. So to find out if it's convincing, we're going to calculate our standardized test statistic, and we're going to find our p-value. So our standardized test statistic is z. So what I did is right here, I'm going to do p. I'm going to find my standard deviation, or my z-value, p statistic minus parameter over the standard deviation. Statistic minus parameter over the standard deviation. You can see I get a z-value of 1.19, and a z-score of 1.19 is not unusual. But let's convert that to a p-value. So we're going to go into our statistic menu, find the probability that we're at this z-score. So my normal CDF says lower is 1.19 because I want this or greater. So that's why I'm doing the upper. So I get 0.1170. There's my p-value. And then is that an unusual p-value? Well, I'd compare that to alpha. So what conclusion could I make? Well, because my p-value is greater than alpha, 0.1170 is greater than 0.05, we failed to reject my null hypothesis. Please notice I said fail to reject. I didn't say we believe the null hypothesis. I said we don't reject it. So there, and then I'm going to say why. Why am I not rejecting the null hypothesis? Because there is no convincing evidence that the true proportion of all students at this elementary school who typically walk to school is greater than 0.13. So I believe it happened once. So did it? So I do not reject my null hypothesis. So because once again, it was for one sample. So does it happen all the time? I don't know. All right. So we're going to now do questions, exercises 4 through 10 on assignment 9.2. If you got questions, let me know.